Okay, so let's pick up with our next table here. We're going to check to see if it shows a proportional relationship between x and y. So again, I'm going to compare y to x. So I'm going to put 9 over 3 and reduce to lowest terms because 9 and 3 both have a common factor of 3. 9 divided by 3 is 3. 3 divided by 3 is 1. So this ratio is 3 to 1. Let's check our next row. Ratio of y to x would be 36 over 12. If I reduce to lowest terms, 12 is the greatest common factor of 12 and 36. 36 divided by 12 is 3. 12 divided by 12 is 1. So far, both rows have a 3 to 1 ratio, so we're proportional so far. Let's check 4/9 to 4/3. I'm going to need a little more space to work this one out. So my y is 4/3, my x is 4/9, so I'm going to write y to x. Since I have a fraction I want to get rid of, I'm going to multiply by the reciprocal. The reciprocal of 4/9 would be 9/4, and I do that so that these will cross cancel. Whatever I do to the bottom of a fraction, I must do the same to the top. So I will multiply the top by 9/4. I notice I can do some cross canceling up here. 4 divided by 4 will cancel to 1, and a 9 and a 3 can cancel because I can divide 3 by 3 to get 1 and 9 by 3 to get 3. So overall, this cancels to 3 over 1 over 1 over 1, which is 3 to 1 ratio. So I have the same 3 to 1 ratio here. As I look at my last row, as long as 4 to 1 1/3 comes out to a 3 to 1 ratio, then we have a proportional relationship. So I'm going to change my mixed number to an improper fraction to start. 3 times 1 is 3, plus 1 is 4, and I'm going to keep my denominator of 3. Now if I want to get rid of my fraction in the denominator, I'm going to multiply by the reciprocal of 4/3, which is 3/4, and I do that so that I can cross cancel. Now whatever I do to the bottom, I have to also do to the top. So I will multiply by 3/4 on the top. 4 times 3/4, I know my 4's will cancel, so I'm left with 3 over 1. So again, I see that 3 to 1 ratio. So I would say that this one is also proportional. Let's check our last table here. I'm going to again compare y to x. So I'm going to compare 4 to 8. Well, I know that 4/8 will reduce to 1/2 because 4 divided by 4 is 1, 8 divided by 4 is 2. In my second row, I'm going to compare y to x, which is 3 to 7. I know that 3/7 is not equivalent to 1/2, and that won't reduce any further. So already I see that I don't have a common ratio. Let's check the last two rows. 2 to 6 would reduce to 1/3, and 1 to 5 is already reduced. So this one is not proportional. Not only did I not have a common ratio, I had a different ratio in each row. Okay, as you practice this further, you're going to follow these same steps. So if I'm looking for a proportional relationship between x and y, I again just need to compare y to x and find a common ratio. So as I put y over x, I'm going to reduce to lowest terms, which this already is, and then compare my ratio to the next row. So I will put 15 to 3, which I know can be reduced. 15 divided by 3 is 5. 3 divided by 3 is 1. So I have a 1 to 5 ratio here, and now a 5 to 1 ratio. So this is not going to be proportional, but let's check out our next row. Since I have fractions, I'm going to get some extra paper to work it out. As I compare y to x, I have 2/5 to 2. If I want to get rid of this denominator because fractions within fractions are messy, then I'm going to multiply by the reciprocal. The reciprocal of 2 is 1/2, and whatever I do to the bottom of the fraction, I have to do to the top. I multiply by the reciprocal because that will cancel to 1. And as I multiply 2/5 times 1/2, I see that my 2's will also cancel. So I end up with a ratio of 1/5 to 1, which we could just say is 1/5. And as I look at my last row here, and I write y to x, that would be 8 to 8/5. Again, I have a fraction I want to get rid of, so I'm going to multiply by the reciprocal. Whatever I do to the bottom, I have to do to the top. I multiply by the reciprocal because that will cancel to 1. And on the top, my 8's cancel, which leaves me with 5. So I have 5 to 1 for this ratio. So even though I have similar ratios, they're actually reciprocals of each other. And it alternates 1/5, 5 to 1, 1/5, 5 to 1. So this would not be proportional because I don't have a common ratio. So as I get to larger numbers, for example, these photocopy costs, if I'm looking at the number of copies and the cost for those copies, and I'm trying to determine if there's a proportional relationship, then I remember that I have to show that with equivalent ratios. So let's see how it plays out. So I will do cost to number of copies, again, y to x. So I will put 18 over 150. Now I'm going to have some reducing to do on this one. So I need to make sure that I find the greatest common factor for 150 and 18. So as I'm thinking through this, I'm thinking that 18 probably does not go into 150. But I know that 9 will go into 18 and 6 will go into 18. So I'm going to see which of those numbers will also go into 150. And once I find that greatest common factor, I can divide the top and the bottom by that greatest common factor. So if I take 150 and 18 each divided by 6, then I can reduce this to lowest terms. So 18 divided by 6 is 3. 150 divided by 6 is 25. So that is my ratio in lowest terms. As I look at my next row, I'm going to compare cost to copies. And again, I need to find the greatest common factor for 27 and 225. So I might first check and see if 27 will go into 255, but it won't. So now I'll think of my other factors of 27. I know 9 times 3 is 27, so I might check to see if 9 will go into 225, and it will. So I can divide the top and the bottom each by 9, my greatest common factor, to get 3 25ths. So far we have a common ratio in our top 2 rows. Let's check out our third row. Cost to number of copies. And I notice on this one that 55 to 550, I know that this will automatically reduce because I know that 55 will be a factor of each of these. So I can reduce by dividing by 55, and that gives me 1/10. So we had a good thing going, but now we have found an uncommon ratio, so I know that this is not a proportional relationship.